All right, thank you for coming tonight. I'm Mark Razor. I'm the principal at Holmes Junior High, and I'm joined by our Holmes counselor, Melissa Taylor, and we'll be co-hosting tonight's event for you. Okay, so this is our third career pathway panel, which is going to be focused on engineering, and I know that that's why most of you are here, is to hear from our engineers that have dedicated their time tonight to having a conversation with us. So before we get started, before I introduce them, I want to go through a couple different housekeeping items. So on your Zoom screen, our speakers should show up on the top portion of it. We've positioned them there so that you won't have to look all around to see who they are. Please make sure to silence your cell phones or kind of put them off to the side so that they don't become a distraction for you. Set your Zoom setting to speaker view, and that'll give you the best experience. So whoever's speaking, they will be the ones who pop up. And then the kind of the run of what we're going to be doing tonight is our panelists will have an opportunity to introduce themselves, to tell you a little bit about what they do as far as in the engineering field. And hopefully that gives you a better idea of what's out there in the field of engineering as part of your career exploration. So at this time, it is my pleasure to introduce our first panelist, Miss Lee Wine. She would then go ahead.
Hi, everyone. Do you want me to go ahead and do my introduction?
Yes, please.
Okay. Well, I'm Lee Wine. I'm a structural engineer. I work at a consulting structural engineering firm in Chicago. We're about 75 engineers. And what is a structural engineer, right? What we do is we work with architects. Architects design the building. They figure out what it's going to look like, how tall it's going to be, how wide, what's the plan, what's the function of the building, and we figure out how it's going to stand up. So we take their requirements and then we figure out what the loads would be for that, and then we evaluate it and we size the floors, the beams, the columns, the foundation, and it's kind of like the bones of the building. So if you think of your skeleton, holds you up every day, that's kind of what we do. We size it. If you've ever seen a building under construction, in that moment in time, that's as far as we go. Once you get the pretty windows and facade and all that kind of stuff, that's the more architectural part of it. So that's kind of where our discipline ends. Someone mentioned that a lot of the kids were interested in listing off all the different careers in engineering. So at least for the construction industry, I can list off the other engineers that we work with also that work with sort of the built environment. So in a building, we also work with mechanical engineers. They figure out how to heat, how to cool, how the machines all work together, how you're going to pump that air through, along with electrical and plumbing, as you might see, especially if you were in like a condo high rise, how do all the toilets flush, how to get water, all that kind of stuff. We also work with geotechnical engineers who are engineers kind of the earth. So our buildings weigh something, right? Something to hold that up. And usually that something is the earth. So whether that's the soil is a sandy soil, a clay soil, or is on bedrock, geotechnical engineers will evaluate the location the building is going to go in and give us requirements for what loads we can partake onto the soil. There's also civil that works with buildings. They kind of figure out the roads, how to bring infrastructure into the building. Some more unique ones that not every project uses might be a wind tunnel engineer. So the taller your building gets, the more difficult it is to design for wind. It gets kind of skinny and tippy. So we might send our models to a wind tunnel engineer. They make almost like a little scale city mock-up because your particular building is affected by other buildings surrounding it, the wind funneling through different buildings. So they have all these really cool strain gauges and stress markers, and then they have a big tunnel and they fan at the end of the room and they blow wind through it. And then they give all that data back to us, and then we use that data to make sure we're sizing our building correctly. A couple others might be environmental, sustainability. So how do we create a building that's better for our environment, has, you know, gives off zero carbons. And then lastly might be like acoustical engineer. And that might be like if you were doing a theater project and sound transmission through different parts in the theater is sort of something that's sensitive to that building. And then I do have like a little model I can show. And I don't know if right now is the right time to do that, but I can try to show you. I've recently worked on a couple, I can just tell you what I've done recently. My last 3 projects were one in Nashville. It was a 24-story concrete building. It was mixed use, so it had like condos and office. I think that was it. And then I worked on a new campus building at the Notre Dame University. And then most recent was a new Chicago Park District headquarters. So the Notre Dame campus was like a 6-story, really heavy, kind of old school kind of building. The one in Nashville was more sort of sleek and glassy. And then the Park District one kind of looks like your basic Park District building with masonry, 2 stories. Kind of look like the Death Star in plan. So that all very different projects. Every new project is a new challenge. So this video I'm going to try to share with you, and hopefully it will work, is it's like a miniature scale of the job in Nashville. So this is the 24-story building, and it's showing how the building reacts to its loads. So it has gravity, so it's kind of pushing down, and you'll see this loop, and then it is reacting to wind in a certain direction. So it's sort of left and right of the page, and then it's in and out of the page. So let me see if I can pull it up and see if it works. Okay, is it showing up?
Yes, it is.
Okay, so what you're seeing is when it goes back and forth, you're seeing, so here it's reacting to wind in this direction. So we make this model, not all the components are in it. It's mostly the sort of parts of the building that resist wind. So we kind of, as engineers, we decide what parts we want to sort of resist the wind and earthquake too. So we have to evaluate that too. So when it, let's see, so this is gravity. This is just its weight and any loads and any people. And so this is wind in this direction. So if you were to blow on this building, this is how it would move. Now, the scale of it, of the movement is ramped up quite a bit just so that we can see how it behaves. It looks like it's moving a lot. You don't see buildings down the street moving like that, but the scale's amped up. So in reality, since it's a 24-story building, in the in and out direction, it moves like 2.5 inches if it were to receive a full wind load. In the other direction, the wind face is smaller, so it moves less. It only moves like 0.6 inches. So this is something that we would typically do once we get a project. We would evaluate the loads, and then we would see what structure we need, define structural elements, and then hopefully hold on to those and tell the architects they can't mess with these are ours. And that's about it. So stop sharing that, hold on. Hopefully I didn't go on too long.
Thank you, Lee. I appreciate you sharing that. That was really cool to see. Students, what we'll do is we'll have some time. We'll ask some more questions, and Ms. Wine will be able to go in a little bit more detail or add on. So now what we'd like to do is introduce Jenny Flonder and have her introduce herself and what she does.
Hi, I'm Jenny Flonder. I put mechanical engineer as my header because that's what I got my degree in from the University of Iowa. But really, my day-to-day job, I'm a safety compliance engineer. So just kind of highlight how getting your degree in one discipline, there's a lot of different avenues you can go out to once you actually start working. So the primary function of my job is that I work for Xylem. It's a water technology company. We primarily specialize in different types of pumps. So hot water circulating pumps that you see in your home, to commercial pumps like fire pumps that go into high rises and different office buildings, where it's the pumps that pump water into those sprinklers that are deployed in those buildings. So my primary function is for safety compliance is that a lot of these local jurisdictions have regulations that the products that come into their building have to have different fire and electrical safety standards they have to adhere to. So I help regulate and make sure that we're staying on top of those certifications, so we're able to sell our products into those markets. So and there's anything from, like I said, fire and electrical safety are the two biggest ones, but it's a growing thing across the country that and the world really, with like different regulations for water safety, for different materials that can come into your product that it can't come from like conflict regions in Africa. So it's like conflict minerals. So there's a lot of different regulations that our products have to adhere to. So really I cross-functionally work over all the products that we are selling through my company to make sure that we're able to put those on the market, the various safety hazards that we see out there. So again, I've been doing that about 15 years now. I got my start doing that at one of the safety agencies now as a manufacturing company I go to. So really I worked for about 8 years with my previous company that I really kind of learned all the skills that you don't necessarily learn until you're on the job, and then. And I was now able to use that in my current job, and I work with a lot of my old colleagues. So it was good that I maintained good relationships with everybody, because now I kind of know how that system works, and I'm able to to bring that specialized skill to my company, and make sure that I stay on top of all the changing regulations that happen. They're constantly changing with especially we're talking about all the material safety stuff that's going on right now. So. But yeah, so.
Thank you, Jenny.
Yep.
Appreciate it. Next up is David Trevino. David, you want to go ahead and introduce yourself?
Hi, everyone. I'm David Trevino. Like you said, I graduated from the University of Kansas in 2019. Upon graduation, I started with ExxonMobil at the Baton Rouge refinery, and I switched over from oil and gas to chemicals. And so that brought me up here to Chicago. And so basically what I've done on a day-to-day basis, I was a process engineer with Exxon. I'm currently production engineer with Stepan, but all in all, it's kind of the same. in chemical engineering, typically in manufacturing, we have raw materials, things that aren't really valuable, and we heat them up, we cool them down, we put them under pressure, or we put them under vacuums in these large process equipment to get reactions, to break chemicals apart, to put chemicals together so we can make valuable products. And the products is what we sell. And so a lot of that requires on-site support from operations. Those are the folks that are out there in the field turning valves. If you ever driven in the middle of nowhere and saw these large like equipment that light up in the dark and like there's steam coming out from the towers, there's a chemical engineer working there, very likely. And so those operations are the folks that tend to the equipment. They're kind of like the first line of attack in case something goes wrong, or a product is out of spec, which means we got to fix it, or a valve gets broken and we can't run like we should. And then I provide technical support to the operations team. So whenever things get a little too complicated and they need a little bit more chemistry support or some more kind of thermo or heat transfer support, then I kind of step in, take their information, build a case on, how are we going to troubleshoot this issue? Can we do experiments to find out what the issue actually is? Because you got to solve the problem. You can't just solve the symptoms. Otherwise, it'll probably happen again. And that's kind of what I do on a day-to-day basis. So usually for work, I wear flame-resistant clothing, very heavy, stiff clothing. I have a hard hat. I wear radio. I got my goggles on, and I got my gloves on, and I'm in the field. And then sometimes when I need to, do some calculations, I'll go into my office and do my little calculations on my Excel spreadsheet, or look at models that I need to look at for whatever reason. And so that's kind of like the gist of my work. Every day, there's something new. A lot of these plants are pretty old. They look old from the outside. And so things break down, right? And so I got to be able to support my team and say, okay, well, if this breaks down, how are we going to keep running so we can still make money, but like do it so safely? And how are we going to make sure that we don't run into process upset, because we want to run as often and as frequently as we can. So there's kind of an optimizing component to my job is, how do we solve problems, but how do we solve them by, spending the least amount of money, but also making sure that we get as much valuable product as we can from all those reactions that are happening in the process equipment. And so that's kind of one component of chemical engineering. Typically, you'll find that in oil and gas or specialty chemicals. Oil and gas being like gasoline, jet fuel, aviation gas. Specialty chemicals, I guess isopropyl alcohol, what goes into Germ-X, which we've all become very familiar with, is a specialty chemical. So those require chemical engineers to make. Some chemical engineers go into material science. So from the materials that make up your iPhone or even the laptop that you're listening to this on, to materials that make up airplane parts, those are chemicals at the end of the day, and they have bonds, and they need chemical engineers to understand them. Sometimes we're working environmental engineering, so with water kind of treatment facilities. And other times, I actually know a couple of chemical engineers that ended up going to medical school. So, you got a variety of options and industries to select.
Thank you, David. That was awesome. Next up, David Guerrero, if you could share about being a civil engineer.
Hi, good evening, everyone. My name's David Guerrero, and I'm a civil engineer. At least that's what's on my my degree. I ended up also getting a master's in civil engineering, but I specialized in water resources engineering, which in all the main goal of mine is to make sure that nothing floods, and especially buildings. That's primarily what I deal with on a day-to-day basis. I decide at what elevation the building should go in. Once I hear back from either the architect or structural engineers. I know Lee kind of rambled off all the other engineers that she deals with. We deal with pretty similar also engineers. Basically, I take everything from outside the building and anything that's underground and design that. whether it can be like where the sanitary goes, the storm water from the building or from the site, as well as any water that needs to be fed to the building as well. A couple projects that I've worked on. I know I did the Glenview Ice Center expansion, which is not too far from where you guys are. I am also the engineer, the civil engineer for your sister school district, District 214. So I've done a lot of work over the summer for those high schools, and I'll be doing more work for this upcoming summer as well. But yeah, that's basically on my day-to-day basis. I basically design parking lots, as well as any like drainage issues that may be going on the site, to help, again, not help basically the building and any surrounding areas not flood, as well as help not flood your neighbors as well. That's the big thing there. Nope, you're muted, I believe.
David, is there anything in 214 that you've done recently?
I did work at we did work at Forest View, Buffalo Grove, and Elk Grove High School. We did redo all their parking lots as of right now. I know some of their schools are going to get their tennis courts redone, but we're mainly working everything on the surface currently. Not unless you guys plan some big expansion of your buildings. Other than that, that's primarily what we're going to be doing for you guys. And then we'll be doing, I believe, Rolling Meadows, Wheeling High School, Hersey High School, as your next couple projects for the summer.
Awesome. Thank you so much for sharing. Next up on our panelist is Michelle Young.
Hi, good evening, everyone. My name's Michelle Young. I graduated from the University of Illinois in 2005 with a degree in mechanical engineering. I currently work for a company called Northrop Grumman. It's a huge company. The division that I work for, though, we make rockets. So that's what brought me out to Utah, where I am now. So we make rockets. I started out in terms of engineering. I've done quality engineering, manufacturing engineering, project engineering, but my role currently is something called business development. So I've been able to morph my engineering background into more of a technical sales role now, using all of my technical knowledge to actually try to sell more rocket motors or find more uses for our rocket motors. In terms of projects that I have worked on currently or recently, I have worked on the Space Shuttle project. So long before there was SpaceX and the Falcon 9, there was something called the Space Shuttle. So I worked on that project when I first hired in. I also support the Navy in a submarine launched ballistic missile called the Trident II. I also support the Air Force on a brand new rocket motor called the Ground-Based Strategic Deterrent. And I have also recently worked with ULA, United Launch Alliance, to make their GEM 63 rocket motors for their Atlas V vehicle. So I'll just very quickly, because I know we have limited time, I just want to say, even though I have a mechanical engineering background, I'm now at an aerospace company, and just like the other folks have noted, you really, at least with Northrop, you can have any kind of degree under the sun and support an aerospace company like Northrop. We hire chemical engineers, mechanical engineers, civil, electrical, material science, structural, environmental engineers, really anything and everything under the sun. So thanks for having me.
Thank you for being here. So Sarah, you got to follow up a rocket engineer. Okay, so why don't you go ahead and introduce yourself, Sarah?
Hi, my name is Sarah. I am a senior at Elk Grove High School. I have taken probably almost all of the classes from PLTW. I know my teachers are probably sick and tired of me from being in that wing, because I'm usually always there. But I'm not sure what to say, honestly. It's been quite an experience. I have taken, there's a wide variety of like from introduction to engineering, which just covers like the basics, shows you some computer programs. I know I've worked with Autodesk Inventor, Revit, and Fusion. I've also taken digital electronics. I'm currently taking civil engineering and then aerospace. I've also worked in the metal area, I guess you could say. I've worked with the CNC machines. I worked with the manual blades. I've done welding, and I've also done robotics. If you are a student that is interested in robotics, please join because it is very fun, and you shouldn't miss out on that experience. It's once in a lifetime. I really wish I would have joined robotics quite sooner. It's a little sad because it's my last year and I really didn't enjoy it as much. Well, because I joined last year and now this is my last year in school. The course like work that's revolves around PLTW is more like hands-on and like computer based. I know you get about two big projects, and then you have little like work or like little projects that go on as well. If you're interested in it, you should join. I know I did not take the PLTW courses in middle school because I was in band and transfer student, so I didn't get into that. And well, you should just join. It's just very fun. Teachers are very nice. They're very, very nice. I'm not sure what else to say.
Sarah, can you tell us a little bit about your experience with PLTW and the Harper Promise and how that's come about for you this year?
Well, sorry. Okay, so the Harper Promise is a program that is in partnership with Harper, the college. It starts your freshman year, your second semester, and it goes all the way through your senior year. You have to maintain a good grades of at least a C. You have to do some volunteer work, and you're supposed to have just good record. That's literally all they ask, and they will give you 2 years free of college. They will give you a scholarship, and you can choose whatever coursework you want from Harper. And it is a very good program. I recommend you to sign up and to keep it going because you never know, you might end up going there as a backup plan or just different situations. I know I've received some volunteer work service with the PLTW course. There's a program that I'm not sure if the students here have participated in the Next Generation Engineer program. I know I volunteered as a student teacher and I was helping here and there last year. I'm not sure if they're going to do it this year, but I really hope they do. They gave me work there. It was good. I'm not sure what else to say. I'm sorry.
That's okay. Thank you, Sarah. I appreciate it. So what I'm going to do is start asking some of the questions that we have. And I know Ms. Taylor has put in there several messages out there. Kids, you guys have any questions for our engineers, just put them in the chat and we'll be able to see them and ask them. So I'm going to start with David Guerrero. David, did you have any champions or role models who helped influence you along this career path, or is this just something that through trial and error you decided on?
I think my parents were probably the biggest advocates for me going to school and keeping up with schoolwork. I think it was their guidance that kind of somewhat guided me into what I wanted to do. When I initially got to college, I wanted to be an architect, but realized that my brain kind of didn't really work in the way that architects kind of work. And I figured that, kind of found out that I'm more into building things myself. So that's where the engineering field, the engineering side kind of helped me narrow it down more or less. And my dad worked in construction. So, you know, seeing and trying to get the idea of how things are built kind of guided me in the civil engineering route of things. So, but yeah, I would have to really thank my parents for trying to push me and guide me in the correct direction, at least, or try their best at least of what they could.
Great, thank you for sharing. Jenny, I'm going to ask you the same thing. Did you have any role models or champions that helped influence you, especially in the field of engineering? I know we have several panelists here that are female, and back when I was in college, that was very rare to have. So,
same with me. So, yeah, I mean, I agree with David. My parents were a huge influence on me. I mean, my dad, neither one of my parents had a college degree. So, you know, they were always pushing me to, you know, to do whatever I wanted to do. And I was always interested in science courses in high school. And, you know, I think I took 2 years of chemistry in high school and ended up taking 3 years of it in college. That was always kind of an area I was very interested in. But yeah, it was actually a geometry class when I was a sophomore in high school that we were just given an assignment where we had to look up a degree that would utilize geometry. And, you know, I just started doing some research and found civil engineering, and it seemed very interesting to me. So you know, that's what I kind of picked, and that's going into college. That was what I kind of, you know, thought I'd go into. And, you know, and all the teachers and everything like that, they, you know, encouraged, especially me being a female, going, because I think I was one of 2 female engineers in my graduating class in college. But yeah, I mean, you know, so civil engineering sounded like a good idea. I ended up doing mechanical engineering once I got to college and saw what was out there. But yeah, it was always my parents who definitely pushed me, whether it was, you know, because I was always busy with sports as well, but they always, you know, pushed me to keep, if I was interested in it, to get, you know, to keep going with the courses. And it was hard, but they always, you know, if anything, I was always really hard on myself too, but they always encouraged me to keep going with it, because yeah, it's not always easy, but you know, it's a rewarding thing to push through and to be able to get your degree in it. So yeah, parents for sure.
Thank you, Jenny. So what I'd like to know is from Lee, would be the next one, is what kind of drew you to engineering throughout your career or throughout your childhood?
Well, my first thought is that it, you know, it's, yeah.
Your parents are on here, so I just want you to know that probably should mention them too. Just go ahead.
It was my parents, all my parents. So I found it hard to figure out what I wanted to do. I remember in high school, they gave you a manual of careers, right? And I really liked math, and I knew I wanted to do something with math. So I think that's what guided me through the manual. I thought I had narrowed it down to 3 things: accounting, architecture, and actuarial science. So I took a accounting class, hated it. And then I took a mechanical drafting class, which I think some of the junior high kids said that they had taken something similar, taking an object and drawing 2D drawings of it in different perspectives. That's exactly what that class was, and I really enjoyed it. And then I think the next semester version of that was Architecture 1, which was more, basically we took like house plans out of a catalog and made elevation perspectives and stuff like that. So it wasn't, so I thought I wanted to do architecture. What I realized, and David mentioned this too, is that it wasn't exactly what I thought it was going to be. It wasn't as much math, and it was much more creative, and I did fine, but I just didn't feel like it was my level. My brain didn't work in that super creative way. I liked formulas. I wanted an answer. So I kind of drifted away. Our architecture, I went to U of I, and there's a 4+2 program. So you go 4 years for your undergrad, and then 2 years you can pick a focus. You do construction administration, you can do design, you can do historic preservation, and then there's a couple others, and then structures. So that was all the math classes that engineers take in the engineering department, sort of whittled down in our little grad program. And I like, that was exactly the right fit. So that's kind of where I ended up. And did I answer your question with that?
I think you did. I think you did. You know, it basically was, you went through trial and error to, you know, kind of figure out. I mean, actual science to engineering is a you know, pretty big leap. I guess it's still a lot of numbers and stuff, but and equations. But wow, that's
right. And I guess my advice would be just to stay open-minded. You know, take things that interest you, look into them, try to figure it out now more than later. Luckily, I was able to adapt pretty easily into into finding what I wanted. So yeah, a lot of doors open, even though some's closed. So
thank you, Lee. Michelle, my next question is for you. What I'd like to know, or what the kids would like to know, is how is perseverance and grit? How have you used that throughout your work as an engineer?
Sure, thanks for that question. So with engineering out in the real world, it's very unlike school, right? There are no step-by-step instructions that you can just look up to solve a problem. And a lot of times there isn't just one right answer. And so you really need to persevere when you are given a new challenge, because likely you're the one that's going to have to figure out how to solve that problem. To me, engineering, it's hard to define, but I think it boils down to solving complex problems in a very simple way. That's what engineers do. We solve complex problems as simply as we can. And it takes a lot of perseverance to figure out that simple or elegant solution to a complex problem. So yeah, a lot of stick-to-itiveness, because a lot of the projects that we're working on, whether it's structures in the city or school buildings, these aren't things that you can just say, well, I don't know what the answer is, I'm just going to give up. Certainly you can't just give up on launching a rocket. You know, there are a lot of people out there counting on you, so you really have to stick to it and figure it out.
Yeah, thank you very much. Yeah, that's and not giving up on launching the rocket. That's a great metaphor, right? David Trevino, this question is for you. When you were in middle school and high school, what were some of your favorite classes? What was your favorite coursework?
Honestly, my favorite coursework had nothing to do with math or science. I was really into the theater arts and choir. So I loved singing, and I liked, you know, being in plays and musicals. And so those were my favorite. But I did like math. You know, math was, you know, it really touched my heart. It was fun. I like kind of like the puzzles with the numbers and all the different equations. And it's so satisfying when you can put X equals something that looks like a pretty number, you know? And so, but yeah, I would say honestly, my favorite coursework were kind of my passions that existed outside of STEM, which was, you know, singing.
So, David, I'm gonna stay with you for a second. So obviously, it wasn't your first passion, first love, right? So, what is the most fulfilling part of being a chemical engineer?
So there's really two parts to this. The first part is working with people. Like, I get to work with maintenance folks. Those are the folks that fix our equipment when it breaks. I get to work with operators who have been working at this place for 15, 20 plus years. I get to work with engineers who are a lot more, smarter, have a lot more technical knowledge than I do. And I also get to work with laboratory folks, so just a variety of backgrounds that make up my team, and being able to, get to know them as individuals, but also like pick each other's brains when it comes to solving, the problems that we, the fires that we fight every day. That's a pretty fulfilling experience. It's just like, we're all kind of in this together to achieve the same goal, even though, we don't always agree. Something that Michelle mentioned was like, there's lots of different ways to solve a problem. And sometimes you kind of gotta be firm with your solution if it's something that you believe in. So, there's contention sometimes and disagreements, but, at the end of the day, we're there to do our job safely and do it well, And then the other part is when a problem is solved, the onset, something breaks and we got to try and figure out why, and we don't have the most data on it. And so trying to figure out how to work with things that we don't know, things that are new to everybody, it's not, sometimes we have the same problems, and then sometimes we have completely new problems that no one's ever had to deal with. And so we have to be able to work around that. But it feels pretty good being able to give something, a stamp that says, this was our conclusion, this was the team's decision, and this is how we're going to avoid that problem in the future. It's, a satisfying feeling just to have a job done.
Thank you for sharing that. So along those lines, I'm going to ask the other four, and I'll start with David Guerrero. What excites you about your job? What excites you about going to work every day?
I would have to say that every day is different. I think every engineering problem is different, and there's different ways to solve it. There's not really one solution. In the real world, it's about the client's money, and you want to find a solution with the least cost. But, being able to see, for me, especially being able to see the client's reaction, when you solve a problem or something that they've been trying to solve for, who knows, months or years. And, I find that satisfactory on my end.
Thanks, man. Appreciate that. Michelle, what do you find to be exciting about going into work every day?
I mean, naturally, it's the type of work that I get to work on, knowing that I'm literally protecting our country from adversaries on the other side of the world. But besides that, it's the people that we work with. They're the ones that I really love to visit in the office and chat with and get to know them on a personal level. So sometimes it's not even just about the projects, but it's the people that you really want to work with and work for.
Jenny, what do you
Yeah, I was going to say just like the collaborative effort, because just doing my function alone wouldn't help us be able to sell our products. But I work with other people in my division who are designing the products, and we all kind of, our collaborative effort helps us. It's nice to be able to work with a group of people who are all working towards the same goal, and we're able to kind of come together to get something that is like an either continuing to build on a product that we've already established, or working on a new product to be able to help solve water problems that are happening around the world. So it's nice to be able to kind of going on that path with some really great coworkers and other engineers as well.
Thank you, Jen. Lee, I'll give you the opportunity to answer that same question. What excites you about going in every day?
Similar to what someone else said, is that every new project there comes a new challenge, and you may have had courses and there's a textbook example, but in the real world, that textbook example never applies. So being collaborative with your coworkers and say, here's my issue, here's what should be done, I think I'm going to apply it this way, and then bounce ideas off of them. And then eventually you get a solution. And then going through that process is a little tedious, but then when you find the answer and you feel like you have a rock solid solution to that, it feels pretty good. And then comes the next day where a new one comes up.
Awesome. Sounds like being a teacher too.
I bet.
Ms. Nickel. So what I'd like to do is go to David Trevino for a second, and I'll ask you, what if you think back in time to when you were a middle schooler? We've got about, between 40, 45 kids on here. What advice would you give to little David Trevino back in middle school?
I think the most useful advice I could probably give to myself is to not be afraid to ask questions. I think throughout middle school and throughout high school, I was always nervous for no reason at all. I was just nervous to ask a question, especially if it was in the middle of the class and everyone's eyes were going to be on me. I didn't want to be that kid, right? And it wasn't until I got older where I realized asking questions saves me. It saves me time. It saves me energy. So parents, if you have a student who asks why all the time, they're going to be a good engineer, because that's all I do now is I ask questions. I ask why so many times. And when we don't have the answer, that's when I got to get my team together and we got to solve the problem as to why something happened. But I wish I took advantage of just being able to ask questions. And it's a fear that I think a lot of students can resonate with. We don't want to seem unintelligent. We don't want to be the one that asks the question that maybe the teacher already answered and we weren't paying attention, or it kind of just went over our head, but don't be afraid to ask questions. That is going to help you in the end. It'll get you the answers that you need. And so I'm just thinking of a time when, I would be talking with my teacher or whatnot, and I would go back home and my mom would be like, "Oh, so what did the teacher say?" And I said, "I don't know," and it's not always the best thing to do. So don't be afraid to ask questions. Questions get you answers, and that's what you need.
Awesome. Thank you, David. David Guerrero, I'm going to pose that same question to you. What would you tell your middle school self?
It's funny because I actually had that same note on my notes over here too. I would definitely agree with David is don't be afraid to ask questions. It's something that I wish I would have done in middle school and high school. To add to that as well is, learn to accept criticism as well. Everyone's going to critique you one way or another, but learning to accept it and learning to use it to your advantage, will make you a great engineer as well.
Thank you, David. So Sarah, you are the closest to middle school of our panelists, I think. What advice would you give your middle school self if you could go back, 4 or 5 years?
I would agree with David T. I would self-advocate because it is very important, especially now. Students right now, I feel like they have it pretty hard because there's low motivation right now. I'll be honest with you, there's very low motivation, and things around aren't helping as much. So you always have to ask for help, and don't be ashamed of it because it's natural. Humans love to ask questions. They want to learn, I would say that, and get out of your comfort zone. Personally, as a girl, I would say do it. Why? Because it's just, you just have to, because maybe you'll be able to just do beyond what you would imagine, because personal experience, people would just, "Oh, she's a girl, it's fine, your work is all right, it's not good, it's all right, it's mediocre." But you just have to push boundaries. You just have to keep on going, persevere, because that's just how it should be. You shouldn't confine yourself into a little box. Think outside the box, because that's what's gonna produce the best ideas. I would say that to my younger self, like just get out of your comfort zone, ask questions, don't be afraid, because that's just going to limit yourself, and you don't want that. You want to be beyond.
Thank you for sharing that. I really appreciate it, Sarah, for you being vulnerable and sharing that story with our kids. You know, I think that that's an important, there's two things that she touched on there, as being a female in engineering, and we've got a tremendous group of panelists here that are, and then also working in the pandemic, right? So I want to kind of still stick with the concept of being a female in engineering. And Michelle, if you could kind of tell us about your experience in middle school and high school, and how you have navigated, you know, working for Northrop as a female in engineering.
Sure. I'll go ahead and say that I think it's really important to recognize that being a female engineer is not a weakness. If anything, it's a strength, because right now we are a minority, and you know, there's a lot of emphasis on equality these days, right? So people are actually looking a lot more, trying to find the female engineers. What is their voice? What is their opinion? As females, and some of us have families, we raise kids, we just have a different perspective to offer than males. So really don't look at being a female as a weakness, it's a strength. And then especially for, you know, girls, when you're in these engineering classes, you know, that just means they're more boys to meet. So that's always a plus too, you know, a lot more just guys to be on your radar. But yeah, so I would say for me personally, being a female in engineering has really been a positive thing, that it gives me more of an opportunity to be highlighted because I'm a female.
Thank you very much. And so you brought up a good point, is working right now in this time and being, you know, a mother working during the pandemic. And so one of the questions that we've got is, how has the pandemic changed your work right now? How has it changed how you're working as an engineer? And so I'd like to go to Jenny and see how that's impacted your work.
So yeah, so I've been working from home full time, and so also been home with my husband, who's also an engineer. He's been working from home full time, and then we have 2 little kids running around as well. So multitasking has become a priority. We you know, take turns assisting, you know, where, you know, with if we have meetings that if the kids need attention while one person's in a meeting, it's you know, it's you know, learning to who needs the communication to realize who needs to take priority. But most of my job could have been done remotely to begin with. I mean, we do definitely miss the one-on-one interactions with my colleagues, because believe me, it's a lot easier to just pop over to somebody's desk to ask a question, you know, talk over something. And now it has to be, you know, there's a variety of other tools that are at disposal now, whether it be, you know, talking on the phone, or, you know, doing video calls like this, or instant messaging. But yeah, I mean, it is something you do miss out on, but yeah, everybody's kind of making it work. You know, it's my company is still considered an essential business, so people who have to go in can go in. I know I've been fortunate that most of my job is able to be done remotely. But yeah, it is a day-to-day struggle over, you know, just trying to fit everything in. And, you know, it's sometimes it's working later at night or earlier in the morning to be able to get everything in. But, you know, we've been getting by. So.
Thank you. Lee, I'd like to stick with that question. How has the pandemic changed some of the work that you've been doing?
Well, actually, I was working from home even before all this started. I switched to part-time when our 3rd child was born, to sort of scale back my hours a little bit. And then I worked from home so I could, you know, someone's always sick at least once a week, or someone has something going on. So it's just nice to be here. So it's actually been great for me because now all my coworkers are remote. So we're kind of on a level playing field. So maybe I'm not the best person to say how things have switched. It's actually been better for me.
Well, that's okay. And sometimes that happens, right? Some of it's the byproducts are good, and some of them are just a change. And so, David Trevino, as a chemical engineer, have you seen any difference for the pandemic or from the pandemic?
Yeah, I guess in all transparency, I was actually laid off because of the pandemic from my first job. And, you know, when we talk about perseverance, you got to show perseverance at work, but like you also got to take charge of, you know, what happens outside of work. And, you know, that was an unfortunate reality with, you know, gasoline prices down, no one's flying, so jet fuel is down, aviation gas we're not selling, crude oversupply. Like there's just so many factors that, you know, was kind of drowning the business that I was a part of. And so in that event, you know, there was that component of, you know, there is a reality that businesses have to make money, and I'm a part of this business trying to support it. But something like, you know, a global pandemic can have those brutal impacts. And so, you know, transitioning into chemicals, I had to be strategic. And so I was looking at companies that had been doing well during this. And the company that I work for makes a lot of intermediates and byproducts for cleaning detergents and Germex and viral solutions. And so these are companies that produce these, you know, products are going to be in high demand. So I had to be strategic about what my next move was going to be. And, you know, piggybacking off of that, I had to start a new job in a pandemic where I couldn't meet. I still haven't met a majority of my team face to face. You know, one of the most important interfaces that I have with my particular job is my interface with operations. Those are the folks that you know, handle the equipment and that are, you know, turning valves and pushing buttons and, you know, making this process equipment work. And I rely on a lot of their input, and I can't even, you know, speak with them. I have to call them on the phone. And so they can't point to me, you know, this is what happens when I do this. And I have to, you know, kind of like put all the puzzle pieces together and make a story of my own to try and troubleshoot their issues. And so it's been challenging, but I think overall, you know, with the perseverance and the teamwork attitude, like you can make light of those kinds of situations. And that's something that engineering teaches you. It teaches you how to persevere through the hard challenge, through the, you know, the complex problem solving. It teaches you how to work with other people, even if you don't see eye to eye. In this case, it's not that I don't see eye to eye. Well, I literally don't see eye to eye with them. I can't see them because everything's remote. But, you know, I'm still going into work. I'm making the most out of I can with my new relationships. And I just have to be confident in my ability so that I can still contribute to my team while doing everything remotely and while being new.
Thank you, David. I think that encompasses a lot of the different questions that we've had, and you know, the different experiences that you've shared and messages as a group that you've shared with our students about, you know, perseverance and grit and finding a way through it, right? And that's very important during this time, and your experience in this micro time length here over the last 9 months. You've had to do it all. So I appreciate that, and we wish you the very best, and thank you for sharing that story. So time is now 7:32. So I want to thank all of our panelists: David Trevino, Michelle Young, Lee Wine, Jenny Flonder, David Guerrero, and Sarah Carbajal for being here with us tonight. I want to thank our co-host Melissa Taylor, who has been monitoring the chat and making sure that nothing went wrong and I didn't screw up anything with unmuting people. So, and then thank the great Bob Murphy, principal at Friendship, for joining us, and Miss Nickel for being here as a PLTW teacher, and all of our counselors at the junior high level across District 59. Thank you all for, again, joining us tonight. We appreciate your time. kids, I hope you guys learned a lot of information. I hope some of you became inspired and want to go down a path of exploration. Please make sure to sign up for our PLTW classes if you're in 6th and 7th grade, and if you're off to one of the District 214, whether it's Meadows, Prospect, or Elk Grove, look into those classes. And we look forward to seeing you guys back on Zoom tomorrow morning, 9 a.m. Thank you very much. Have a great night.